When you think of hose, you may see a garden hose in your mind, but hoses actually exist for a wide variety of uses. This program is about the various hose manufacturing methods and the wide selection of chemical compounds and materials used for the components of hose that result in the tremendous versatility of hose. Basically, hose is a flexible pipe used to transfer or convey material from one point to another. Some common examples are hoses that convey gasoline, compressed air, or hot water with detergents under high pressure. But hoses also used in a wide variety of applications that may not be as familiar. For example, hoses used to transfer most food and beverages that we consume. All types of industries use hose to transfer a variety of chemicals, steam, and even solid materials. In addition to the wide variety of materials transferred by hose, some hoses must be able to withstand high internal pressures, while others must be able to withstand high internal vacuum. Let's begin the study of industrial hose by looking at the components of our flexible pipe. Most hoses have three component parts: tube, reinforcement, and cover. The tube is the inside portion of the hose that is in contact with the material being transferred. The inside cross-sectional measurement of the tube is the inside diameter. The inside diameter, or ID, is the basic identifying dimension of the hose. For example, a 1-inch hose means that it has an ID of 1 inch. The reinforcement of the hose gives the tube the strength to withstand pressure or vacuum. The primary function of the cover is to protect the reinforcement from external damage such as abrasion, chemicals, and sunlight. The cross-section measurement of the outside of the cover determines the outside diameter, or OD, of the hose. The tube and cover are generally manufactured with various kinds of rubber or other chemical compounds to resist damage and to improve the life of the hose. A specific compound will generally be blended to have good resistance to one or more of the materials and conditions that shorten the life of rubber, such as abrasion, weather, and ozone, heat, and oil. Abrasion is the gradual wearing away due to a rubbing action. Sunlight contains many light rays that cause rubber to get brittle and crack. Ozone is present around many types of electrical apparatus and causes rubber to crack. Heat causes rubber to age and get brittle. Oil causes rubber to swell and get spongy. Tube compounds are generally selected to have good resistance to the material being transferred, such as oil, steam, or chemicals. Cover compounds are selected to have good resistance to external conditions, such as abrasion, weather, and ozone. Therefore, it is very common for a hose to have a tube compound that is different than the cover compound. Tube and cover compounds can be a variety of colors, if desired, for a given application. Tube compounds are generally black, although other colors are used. When a hose is used to transfer edible food products, such as milk or flour, the tube is generally white, so it can easily be inspected for cleanliness. These compounds must meet the requirements of the Food and Drug Administration, or FDA. Most industrial hose manufacturers list in their catalogs their specific compounds available and the resistance of them to various materials and conditions, as well as other physical properties. The reinforcement of the hose, as said previously, is generally a fabric, yarn, or wire, or a combination of these materials. The strength of a hose reinforcement in regards to its ability to withstand internal pressure is referred to as its working pressure rating, expressed in pounds per square inch. This is often abbreviated as PSI. The strength of the hose in regards to its ability to withstand internal vacuum or suction is referred to as its suction or vacuum rating. This rating is expressed in inches of mercury, abbreviated as shown here. since Hg is the chemical symbol for mercury. A vacuum rating of 30 inches of mercury is considered to be a full suction rating in general industry. The minimum bend radius is the maximum amount that the hose can be bent without causing damage, shortened service life, or restricted flow. This measurement is to the inside of the bend curvature. Twice this dimension gives the minimum bend diameter, or circle, that the hose can form. The type of reinforcement, as well as ID of the hose, has a significant effect on the minimum bend radius of many hoses. The method of manufacture also affects the minimum bend radius of a hose. Common terms used to describe the various hose manufacturing methods are vertical braid, horizontal braid, spiral, and wrapped construction. Vertical braid hose has a seamless extruded rubber tube. The reinforcement is applied over the tube as the tube passes vertically through machines called braiders. The braided reinforcement material is a yarn, cord, or wire, and the machine forms the braid directly over the tube. Either one or multiple layers of braid can be applied, each separated by a layer of rubber. The cover is then applied over the reinforcement, and the hose is cured or vulcanized with heat. The purpose of vulcanization is to cure the raw rubber and make all component parts homogeneous. This construction is very economical and is common for air and water hose. It gives the advantage of long continuous lengths in diameters of 3/16 through 2-inch ID in low to medium range working pressures. Some hose constructed in this manner utilize a flexible rod or mandrel to support the tube during manufacture. The long flexible mandrel is made of plastic or rubber and permits the application of stronger reinforcement over the outside of the tube. This construction gives the advantage of long length, but with higher working pressure rating and closer tolerances on the ID. The inside diameter is generally limited to 1-inch ID maximum. This construction is common for air and general service hose. The horizontal braided hoses are constructed on a rigid mandrel, which is generally a steel pole. A seamless rubber tube is constructed on the mandrel, which supports the tube during manufacture. The mandrel supports either wire or textile reinforcement to be applied at high tensions. This permits construction of a hose with close tolerances on the ID and high working pressure ratings. Sizes are generally limited to 4-inch ID maximum and lengths up to 50 or 60 feet, although some manufacturers offer longer lengths, up to 200 feet. An example of this construction would be this 2-inch ID air hose. Horizontal braid hoses that are to be used for suction applications have an added reinforcing wire spiraled between braids. This results in a hard wall hose with good resistance to collapsing and kinking. Horizontal braid construction is commonly used for steam, heavy-duty air, and petroleum hoses. Spiral reinforcement is another popular method of applying the reinforcement. 2 layers of textile yarns are applied over the tube. One layer is spiraled in a clockwise direction and the other in a counterclockwise direction. This is referred to as 2-spiral hose. Another double spiral may be added to obtain higher working pressure, resulting in a 4-spiral hose. The advantages of spiral reinforcement are excellent flexibility and lower manufacturing cost. This construction is popular for many air and water hoses. Wrapped construction was the earliest form of manufacturing hose. It consists of layers or plies of fabric wrapped around a tube that is formed on and supported by a rigid mandrel or steel pole. A machine may be utilized to apply the layers of fabric. This method results in a hose for discharge applications in lengths up to 200 feet. Machine-wrapped construction offers a variety of tube and cover compounds. It is typically used for water and acid discharge hoses, as well as for sandblast hose. However, it is generally not capable of the higher working pressures available with horizontal braid construction. Suction applications of wrapped hose require the addition of a helical wire included in the reinforcement. This requires that they be hand-built on a mandrel. Larger diameter hoses with or without a helical wire are also hand-built. This method of construction also permits the use of a wide variety of tube and cover compounds. Diameters of hand-built hose can be as much as 36-inch ID, having a capacity to move very large volumes of material. Maximum lengths are from 40 to 50 feet up to 12-inch ID and 30 feet for larger than 12-inch ID hose. Due to the high degree of hand labor involved in this construction, these hoses are relatively expensive. Typical applications of hand-built hose are material handling, bulk petroleum, and where the high volume capacity of a large diameter is required. Most hose constructions have plain ends. This is simply an end resulting from a cut through the cross-section of the hose and is the most common end. However, a variety of hose end treatments are available with hand-built hose. Soft ends refer to hoses with helix wire in the reinforcement, where the wire is omitted from the ends in the coupling area. This permits increased coupling retention when using bands for installation. Enlarged ends are similar, except the ID of the end is enlarged to a greater diameter than the ID of the main body of hose. These ends accommodate fittings that have a larger OD than the ID of the hose. For example, a 4-inch ID pipe nipple has an OD of 4.5 inches. Therefore, the hose end of a 4-inch ID hose with enlarged ends would be enlarged to 4.5 inches. In addition, built-in fittings such as nipples and flanges are available for some hoses. These fittings become an integral part of the hose. There are other types of hose construction, such as circular woven, typical for fire hose, thermoplastic hose, and metal hose. However, the construction methods discussed in this program are the most common for industrial hose. Let's review. Hose is a flexible pipe used to transfer materials from one point to another. The identifying dimension of the hose is its inside diameter, or ID, and length. Other important dimensions are the OD and length. The three basic components of hose are the tube, reinforcement, and cover. The ability of hose to handle such a wide variety of applications is due to the technology of blending the tube and the cover compounds. Compounds are selected to have good resistance to one or more of the materials and conditions that could damage or shorten the life of a hose. Typical examples would be abrasion, weather and ozone, heat and oil, as well as many acids and other chemicals. The ability to withstand pressure is due to the reinforcement. The amount of pressure is referred to as the working pressure, expressed in pounds per square inch, or PSI. Machine-wrapped and hand-built hoses generally have lower working pressures. Vertical braid and spiral non-mandrel-made hoses have medium working pressure ratings. Mandrel-built horizontal braid construction has the highest working pressure rating. The ability to withstand vacuum is generally due to a spiral helix wire included in the reinforcement. The vacuum rating is expressed in inches of mercury. Suction hose is usually horizontal braid or hand-built construction. High volumes of material may be handled with hose having a large ID. Hand-built hoses are capable of diameters up to 36 inches ID. Machine-wrapped and horizontal braid hoses are usually limited to 4-inch ID maximum, while vertical braid hoses have a maximum ID of 2 inches. Most hose manufacturers list in their catalogs the details of construction for their hoses. They also give the necessary information for the selection of the proper hose for a given application. This ensures that industry has a safe, dependable, and versatile tool for transferring a variety of materials under a wide range of operating conditions.